Okay, so this lesson we're going to look at the equation of a line, which is this one here, y equals mx plus c. There's two important things that we want to look at in this lesson, and the first is this value m, the number of x, and that tells us what the gradient of the line is. We've already seen before how to find the gradient of a line in rise over run, or difference in y over difference in x. But if we have the equation of a line, we can tell the gradient just by seeing how many x's there are there. And also then, this value at the end, plus c. This c is an important one. It is what we call the y-intercept. And the y-intercept is simply where it crosses the y-axis. What value does it cross the y-axis at? So we're going to look at a few examples, I guess. And if we can compare any equation of a line to y equals mx plus c, then we should be able to work out what's the gradient of that line, where does it cross the y-axis, and so we'll have a rough idea what it looks like. So a couple of examples here. Try y equals 3x plus 2. So again, look, it's a single y here. Y equals, instead of mx, you can see that that value of m is 3. So the gradient is 3. And the number on its own at the end there is 2. So the y-intercept is 2. Now if we were to draw that very, very quickly, just a quick sketch, then I know that the y-intercept is 2. That's where it crosses the y-axis. So let's just imagine that's 2. And it has a positive gradient of 3. Now, a gradient of 1 splits the diagonal, so 3 is a wee bit more steep than that. So if we draw it, it would look something like that. Let's have another go. Y equals x minus 3. This is a wee bit trickier because you think, well, how many x's? There's no number in front of x. But actually, we know that when there's a single x there with no number, it means there's 1x. And so the gradient here, there's 1x, the gradient is 1. The number on its own, well, it looks like there's 3 at the end, but we just need to be careful because not just 3, it's minus 3. So our value of c, the y-intercept, is negative 3. And if we draw that, or not draw, we quickly sketch, because this isn't accurate, it's just giving us a rough idea what it looks like. Well, c is minus 3, it crosses the y-axis at a negative value, so I'm just going to put below the origin. And the gradient is 1, so the gradient of 1 sort of splits the diagonal, so we're going to do something like that. And that's roughly what our line would look like. So third example here. Y equals 2 minus 3x. We just need to be a little bit careful here because you'll see it's not quite in the same format as here, y equals mx plus c. Here we have y equals a number minus 3x. But all that we need to do is compare the m value with the number of x. So even though these are written out of order, we could rewrite it if we wanted as y equals minus 3x plus 2. Just switch those around, that's fine. But it's just as easy to say, well, how many x's are there here? Well, and just be careful again, there's not just 3 x's, there's minus 3 x's. So m, the gradient, is minus 3. The number on its own then, well, the number on its own is 2. It's positive 2, so c equals 2. And again, if we wanted a quick wee sketch, just to see, well, roughly what does that look like? Well, the y-intercept is at 2, so that's a positive value here. At this time, notice the gradient is negative 3. A negative gradient goes down from left to right. So that's roughly a gradient minus 1, so let's make it a wee bit steeper. And it looks something like that. Just make sure that you label your axes there. Okay, a couple more examples. This one just need to be slightly careful, getting slightly harder now. And the problem with this one is that instead of y equals mx plus c, here we have 2y. And it's absolutely crucial at each time that we have a single y. So what we're going to do is we're going to divide everything by 2. And if I divide 2y by 2, I get y. If I divide 4x by 2, I get 2x. And if I divide 1 by 2, I get a half. I need to divide everything by 2. And now when we compare y equals mx plus c, how many x's are there? There's 2. So my value of m is 2. What's the value of on its own? Positive a half, so c equals a half. And again, we can do a quick sketch of this. It crosses at a half. So again, I'm not doing a really fantastic scale here. I just know that a half is positive, so it's above the x-axis there. And this is our y-axis. And I know that the gradient here is 2, so it's a positive gradient. There's a positive gradient of about 1, so let's go a wee bit steeper than that. Let's go look something like that. Finally, 3y minus 2x plus 12 equals 0. Now here we have a bit of a problem in that it's not in the format y equals something. So first thing I want to do is make sure it's a y term equals something. So I'm going to move these two across the equal sign. And so it's become 3y equals. Now when I move that across, it becomes 2x. And when I move the plus 12 across, it becomes minus 12. So now it's of a form a y term equals so many x plus a number. But like the last example, we don't have 1y, we have 3y. So we're going to divide everything. Just divide everything by 3. So that we can find out what 1y is equal to. And y is equal to. Now 2 divided by 3 is just, we can write it as a fraction, 2/3. Minus 12 divided by 3 is minus 4. So let's sketch that. So again, how many x's have we got? We have 2/3. So the gradient here is 2/3. What's the number on its own? Minus 4. So the y-intercept is negative 4. So if I find my y-intercept at minus 4, the gradient is slightly less than 1. So there's about 1. So let's make it slightly shallower, slightly less steep. And it's going to look something like that. And any time we have the equation of a line, we can reorganize it if we need to. And we can write it as y equals so many x plus a number. M is the gradient, c is the y-intercept. Just want to finish off, excuse me, if I had y equals minus 2x, well in this one you see y equals mx plus c, the value of m here is minus 2. There's nothing on the end, so our value of c here is 0, there's plus nothing. And so when you go to plot something like that, the only thing to realise is that because c is 0, it's going to go through the origin. And because it's a minus and negative gradient, it's going to go down a bit more steeply. And it's going to look something like that. So it does work whenever there's no number there as well.